Hi, this is Atlas and this is Understanding Windows Lateral Movements Part 1. Or better, Understanding Windows User Impersonation. So a little bit about me. I'm Daniel Lopez Jimenez. Those are my socials and I really like Windows and Active Directory security. I'm currently working at the company NCC Group and I also give some master classes on Universidad Castilla-La Mancha here in Spain. This presentation was in fact done or created a few years ago, and I've done it with my college and my friend Elephant Seal, Manuel Leon. You can find him on his socials, and if you don't know him already because of tools like Freshicalls and so on, he's a very curious person. He really enjoys and has a lot of knowledge about Windows internals and about programming and code reviewing, and well, he is also a security consultant at NCC Group. So what's the goal of this presentation? The goal is understanding the art of user impersonation in Windows. Okay, we will understand how to leverage components from Windows authentication to impersonate users, and then use the acquired security context to move laterally into another systems or to perform other tasks like enumeration or whatever. Okay, so more or less the picture of the presentation is something like this. Let's suppose we have compromised user A on host A. So in this presentation, we will see or we will understand techniques for impersonate user B. Let's say we have found credentials for user B somewhere. So we will see techniques to impersonate user B through different kinds of credentials, and then use the new security context of user B to move laterally to another system where he is a privileged user, an administrator, a remote desktop user, or anything. Okay, so the agenda is essentially these 3 points. We will see a section about Windows authentication, its main components and different stuff. Then we will move into user impersonation, essentially playing with all the previous components alongside with stolen credentials. And then the final section will talk a little bit about how to move laterally, leveraging the SSPI. Okay. So starting with Windows authentication, we will see different ways of how to authenticate into a Windows system. Why? Because it's important to know the difference between all of them. Okay. For example, it is not the same authenticating with a local user as doing so with a domain user. Okay. The same applies to authenticating physically in front of a computer or doing so through the network. So starting with local authentication. Local users are only present on specific systems, okay? On a specific system. For example, if we have computer A and there is a local user called Charles, this user will only be present on computer A. There is only one computer A Charles in the world, let's say, because computer A Charles is only known by computer A. So it may happen that different systems have users with similar usernames and even same passwords. Okay, we may find computer A Charles and then in another computer B Charles, and they may have the same password. So as we said before, even if they share the same username and password, they are different accounts because they are stored. The records of these accounts are stored in different places. computer A Charles is stored in a local database on computer A, and the same applies to computer B. Okay, this database is called in Windows the Security Account Manager database, SAM. Okay, so when someone tries to authenticate into a Windows system with a local account, the system takes the logon data and compares it with the records of the SAM database. If the logon data is the expected one, then everything goes smoothly and the user authenticates. Something like this. Hey, I'm host A Atlas, my data is verified, and if it's the expected one, my authentication succeeds. On the other hand, domain users and domain groups are only present in a specific Active Directory domains. Okay, so all domain joined systems or computers from trusted domains will know how to handle authentication for these users. Okay, these systems will not have a database where they check the information, the logon data information that clients provide. What they will do is when someone authenticates, they will delegate the task of checking logon data information to an authentication server. These in Active Directory are called domain controllers. So domain controllers have the database where all the domain user and domain stuff is stored. So quite similar to the previous picture. If we say, hey, I'm domain A Atlas, and I'm authenticating into host A, since host A is domain joined and knows about this domain, the host knows how to handle authentication for that user and then delegates the task to a domain controller. The domain controller verifies the information in NTDS, and if the logon data is the expected one, then the user is authenticated. Okay, so that is for local and domain authentication. What happens with physical and remote authentication? The important thing here is that whereas physical authentication don't require any privilege, okay, if you are in front of a computer and the computer knows about your account, you should be able to log in default configurations, okay? If you are using a local user, you should be able to log in. If you are using a domain user, you should be able to log in, because default configuration of AD, any domain user can log in interactively into any domain computer by default, okay? So yeah, for physical authentications, you don't require privileges, but for remote authentications, you do, okay? Any Windows service that is used to perform remote administration requires some kind of rights or privileges, okay? So if you want to create a remote service on a Windows system, you need to be either an administrator or any other high privilege security group. If you want to access a computer through remote desktop, you must be an administrator or a remote desktop user, and so on. And the important thing here is, okay, remote authentications require privileges, but of course, when we are doing a pen test, we are typically caring about these types, this kind of authentication, the remote ones, okay? So we must be very familiar with the fact that they require privileges, okay? This picture explains well what we have seen, okay? If you are a local or a domain user and you are physically in front of the computer, as long as the computer now knows how to handle authentication for you, you should be able to log in. You won't be able to access other users' information or stuff like that, because access controls still apply. But you should be able to log in, to create your own profile, your own folders, and so on. On the other hand, for remote authentication, note this crown, you require privileges, and for domain users, if you are, for example, a local administrator, you usually can perform remote tasks without many restrictions. For example, you can create a remote service if you are a local admin, okay? But for local users, it is not the same, because the user account control mechanism applies. And if you are using the built-in local administrator account, you should be able to create remote services and do stuff that requires a high integrity context in the system. But if you are not using that account and user account control is configured on the system, it might happen that your context is downgraded and you are not able to perform remote tasks as easy as with a domain user. So please note that. So now in the next section, we're going to be digging into Windows authentication, essentially, and main components of it. For example, we will see authentication packages or security support providers. We will see the difference between interactive and non-interactive authentication. We will see Logon Sessions and then access tokens. So starting with authentication packages. Authentication packages are a component of Windows authentication in charge of analyzing logon data from clients, okay? They are also known as security providers, security support providers, and you have a variety of authentication packages in Windows. Why? Because that provides support for different authentication protocols and different logon processes. Okay, so authentication packages are essentially DLLs, and they are loaded by a component called the Local Security Authority, LSA, right? And these are the default authentication packages provided by Microsoft. Create SSP, Negotiate, NTLM, Kerberos, Digest, Secure Channel. So APIs are not only useful for analyzing logon data. The important thing is that they both are useful, authentication packages, for Windows to act as a client and as an authentication server, okay? So talking about client side, if you are using your Windows and you want to connect to a remote service that supports Windows authentication, okay, and your user has access to that service, when you interact with the remote service with an application that integrates Windows authentication, then your own Windows will transparently select the appropriate authentication package and leverage your cached credentials, okay? So Windows uses your credentials without asking you, so it's like a transparent single sign-on experience, okay? But on the other hand, if you have a service in your system that supports Windows authentication and someone tries to connect to it, the Windows that is running that service will get information, the logon data from clients, and will use the appropriate authentication package to analyze such logon data. To analyze and verify against the appropriate credential database if those credentials are valid and if the user has access. Okay, so APIs are useful for connecting to other services and for authenticating clients in your services. And as we can see here from Windows internals, the captain or the main component that is orchestrating everything is the local security authority component, LSA. We can see that when someone physically logs into a computer, the information is sent to LSA, and here we have the authentication packages. We can see how it checks depending on the type of the user. It might check the Active Directory server, the Active Directory database, NTDS, or the SAM database. And if it needs to delegate authentication, it uses the NetLogon service. Okay. So we mentioned that APIs are useful when you connect to a remote service if your application supports or integrates Windows authentication. So what that essentially means. Microsoft provides something that is called the Security Support Provider Interface, the SSPI. So with this interface, you can implement or integrate your application into the Windows authentication system in a kind of easy way, okay? So you have different functions, you have different functionality that, which if it's used by your program, you can use cached credentials, use authentication packages, and use all of Windows components to authenticate clients or to authenticate into a remote service. Okay, so here is an image of the SSPI page. Okay, you can go there. That is the link. And yeah, the functions are, for example, list all these authentication packages available, credential management, and other stuff. Okay, so what happens when someone succeeds after performing an authentication? What happens is that the authentication package that it's used does two important tasks. The first one is creating a new Logon session, something that is called a new Logon session, okay, within the system. And then the second thing is that the AP provides security information about the authenticated user to LSA. And then LSA uses such information to create something that is called an access token, which represents the user's local security context on that system. Okay? Something like this. A user authenticates into a host either physically or remotely. One authentication package is used, for example, NTLM or Kerberos. Okay? The authentication package used after confirming that authentication is successful, it creates a new Logon session and then provides with information about the user to LSA. This information includes the security identifier of the user, its privileges, the groups where the user is a member, and so on. And also an identifier of the Logon session created. Okay? And then LSA uses this information to create an access token with, all the information. And we can see here that there is a link between the access token and the Logon session through the Logon session ID here. So now let's talk about interactive and non-interactive authentication. This is very important. We have seen like millions of types of authentication already, and this is yet another one. So this one is very important because understanding this will allow us to understand how to move laterally with built-in tools or with tools that integrate with Windows authentication through the SSPI and so on. Okay, so essentially there are two types of authentication here. If you are trying to access a remote service and you are specifying credentials, Windows asks you for credentials, then that authentication is interactive because it requires you to put your credentials. On the other hand, we have the non-interactive, where Windows takes care of the authentication and you don't have to do anything. But of course, such authentication doesn't mean that the service is not supporting authentication. I mean, we require credentials, okay? The only thing is that we are not specifying them because they are already there. So interactive. This one is typically when you log in through the Windows authentication screen. This one, okay? When we do this, we are doing an interactive authentication, all right? The important thing here is that our credentials are cached within the memory of the else LSA component or the LSA process, LSAS. And these credentials are cached and prepared for each of the authentication packages that are present. Okay? These cached credentials, as we mentioned, are the ones responsible, are the reason for doing non-interactive authentication. These cached credentials provide a single sign-on experience where you authenticate one time and then you shouldn't need to authenticate in the next ones because Windows will use your cached credentials. Okay? So yeah, cached credentials allow Windows providing a single sign-on experience. This statement makes sense when talking about non-interactive. So instead of providing credentials, the application in use, which integrates with the SSPI, leverages the cached credentials on behalf of you. Okay? So for example, now if I try to enter to join to access the sysvol share on the domain controller 01, you can see I can access it without providing any credential. And that doesn't mean that access to this share doesn't require credentials. It just means that my cached credentials are being used under the hood thanks to the authentication packages and thanks to the non-interactive authentications. So now let's move on into Logon Sessions. Logon Sessions are created after a successful authentication. It doesn't matter what kind of authentication you do, the target system will create a new Logon Session. Important thing here, cached credentials are always tied to Logon Sessions. Okay, the ones tied to authentication packages are within Logon Sessions. So in which situations are Logon Sessions going to have cached credentials? Well, here we can see an example of Mimikatz. But essentially, Logon Sessions will have cached credentials after an interactive authentication and will, on the other hand, non-interactive authentications or remote authentications will typically result in Logon Sessions without cached credentials. But of course, as it says here, sometimes interactive does not result in cached credentials, and sometimes non-interactive may result in cached credentials. So for reference, I leave this table here and this link with the different types of Logon Sessions, and well, it reusable credentials in LSA session. It explains, well, the different logon types, and also if they end up with cached credentials. Okay, so for example, a network authentication may result in cached credentials when Kerberos delegation is being used, or if you use cred SSP as the package, that one results in usually results in cached credentials. Okay, so I'm going to do a quick demo of this. I'm going to run this one as administrator, which is a Meterpreter session. Okay. Let's wait a little bit. So, how can we check Logon session information and logged on user information from Meterpreter or from any other agent, really? So in the case of Meterpreter, the extended API extension has functionality to interact with WMI, okay? WMI querying commands, WMI query. Okay, so for example, we can select from the Win32 logged on user class the information from that class, and we will see all the different Logon sessions and their identifiers here. So we can see Vegeta, our current user, has many Logon sessions created. And then we have this other class, the Logon session 1, where we can correlate the identifier from the other one to check the authentication package used, the Logon type, start time. Okay, so for example, 487, we can see this one, this Logon session is the result of an authentication using Kerberos, and the Logon type is number 2, which corresponds to interactive. Okay, Logon type 2, interactive. Network, Logon type 3. For example, if we use InPacket to interact with the SMB service, okay, InPacket supports Kerberos, but if you don't specify the use Kerberos flag, it's going to use NTLM. Okay, and of course, this one is going to be a remote authentication. We are connecting to Web 01 through the network from my Ubuntu machine. Okay, so if we check Logon sessions now, we're going to see one NTLM1 Logon type 3, which is a network Logon. Okay, and well, here there are other examples using Lee Christensen's get Logon session script, which is a very good one. Essentially, the classes I'm checking here are the ones that are being checked by this script. The only thing is that this script correlates everything and presents the information in a better way. Okay, so here we can see that this authentication results in an interactive, Logon type interactive authentication from the ACAPath user using Kerberos. And this one, where we use PowerShell remoting to access file server, we can see in file server that a new Logon session is created with Kerberos and network Logon type. Okay, so finally we are going to see what are access tokens. Okay, if we remember, when we authenticate, a new Logon session is created, and then information about the user is sent to the LSA component to create a new token. Okay? So a token is a protected object that contains or that represents the local security context of an authenticated user. Every token is going to be tied to a Logon session or linked to a Logon session through the Logon session ID. And also, access tokens are linked or associated to processes and threads. Okay, something like this. We may have a process with a token, and this token might be for the Bulma user and represents all the security context of Bulma. And then this token has a Logon session identifier which points to, for example, Logon session 1. Okay, a Logon session 1 may have cached credentials. If it is a result of an interactive authentication, it will probably have cached credentials, right? So what information can we find within a token? We can find information such as the security identifier of the user, groups the user is a member of, a list of privileges, the Logon session ID, the integrity level of the process, the type of the token. For example, this. Okay. We can see in the security tab of this cmd.exe process with the PID 3004. The token describes that this user is a CAPATH. This is the security identifier. This is the Logon session identifier. Groups where this user is a member of. The integrity of the process. Privileges. And then the type of the token. We can see it's a primary token. We can see the authentication again. Authentication identifier. So, as we have seen in Meterpreter, it is possible for a user to have different execution contexts, different tokens, and different Logon sessions in the same computer. This is very easy to understand when we talk about user account control. Okay, if we go here and we create a CMD process, and then we create a CMD process running as administrator, we're going to see that they are processes with different tokens. Okay, this token doesn't have privileges, it only has 2, whereas this one has a lot of privileges. We can see the Logon session ID is not the same as this one. Oh, in fact it is. Hold on, let me check this information with Process Explorer because I usually check it with this one. Okay, CMD and CMD. Okay, yes, we can see the Logon session identifier is not the same. Privileges are different, and also the integrity here is medium integrity, whereas here is a high integrity. And also this thing, I usually check it with this one. Advanced, we can check information about the token. Okay, so yeah, user account control is the best way to understand that users can have multiple security contexts in the same computer. So what is the purpose of access tokens really? Windows uses these tokens to carry out access control decisions. Okay. For one hand, we have objects like files, folders, and stuff like that, which have a list of control rules called the DACL, the discretionary access control list. And on the other hand, we have processes and threads which try to access those objects. For example, we have a process that is trying to read a password.txt file. What Windows does is compare the information provided by the access token of the process or the thread against the control rules of the target object. And then confirm if the user represented by the token has access or not. For example, we have passwords.txt and we have an access control list with two rules. Access denied for anyone with this identifier, and access allowed for anyone that is a member of the administrators group. When Winter tries to read, for example, this file, since he has this identifier, the first rule will apply and he's going to have an access denied. But when Atlas tries to write or to read, read or write, yes, since he's a member of the administrators group, he's going to be able to do it. Okay? There are two different types of tokens. We have the primary tokens, which are tokens associated to processes. Okay? They are often called process tokens. And we must know that every process has a primary token. And when a new process is created by an existing process, the default action is inheriting the primary token of the parent. Then we have the impersonation tokens or thread tokens. The important bit here is that impersonation tokens, they are really not very different from primary tokens in terms of the information they have and so on. But there is one main difference, is that impersonation tokens enable threads to run with a different security context. This is a different token than the parent process. And this allows client and server scenarios. For example, we have this service, okay? Imagine we have a web application and the web application is running with this process. And with this token belonging to a service account called service account. So in this case, when a client connects and authenticates into the service with Windows authentication, the result of that is a new thread being created. Thanks to impersonation tokens, the thread created can run after confirming that credentials are valid from the client and so on. It can run with the security context of the client, and then the service can configure access controls like any other object in Windows. Okay, this is better seen in the next slide, but essentially this is called client impersonation in Windows. Okay, so when a client connects to a service, first credentials are verified, then an access token with the security context of the client is created. This token is placed into a new thread, and finally this thread can act on behalf of the client and is subject to the restrictions imposed by access controls. Something like this. Vegeta authenticates into the service. This results in a new thread within the service process with a token representing Vegeta. And then if the application purpose is listing the contents of a folder, for example, Then you can configure in the folders access control list who has access and who not. So here we can see Vegeta has access or full control. So this action is going to work. Okay. And then a final interesting point is that some services may just require limited information from their clients. Okay. Here we are assuming a full impersonation, a full local impersonation of the client. So when he tries to list this folder, well, it works because it has this rule and so on. But maybe some services don't require this full impersonation. So depending how the service is configured and how the client connects, there are different impersonation levels supported. Anonymous, where the server cannot impersonate or identify the client. Identifications, where the server can only get the identity and privileges of the client, but it cannot have a full impersonation. Then security impersonations is the one we are talking about. And then finally security delegation, where this one is the security delegation results in not only a token but also cached credentials. Okay. So that is the first part of understanding Windows lateral movements. In the next one, we are going to start with user impersonation.